Good morning, students. I am Assistant Professor Ritulika Dassidar from Department of Electronics and Communication, BBD University. Today I will be taking the video lecture on the subject Microprocessor and Interfacing with subject code BCS 3502. So my topic for today will be the types of registers which are available in 8085 microprocessor. So basically there is a broad classification between the types of registers. So basically our classification are: we have general purpose registers and we have special purpose registers. In general purpose register, we are provided with B, C, D, E, H, and N, 6 8-bit general purpose registers. We can also use these registers as a register pairs. So B, C, D, E, H, L are the 3 register pairs which will help us to store data of 16-bit. Okay, and the register pairs will be in this order only, like B and C will be only the register pair, B and E cannot be the register pair. Next category is our special purpose register pairs, which is broadly again classified into two parts, that is user accessible and user non-accessible. I'll be taking all these registers in detail in the further slides. So let's talk about first the general purpose registers. In 8085, as I told you earlier, B, C, D, E, H, L are 6 registers which are of 8-bit. We can combine B, C, D, E and H, L to perform any 16-bit operations. The programmers generally use these registers to store data, to copy the data from one register to other. There are many assembly language instructions which you will be seeing in this chapter, in this subject. One more benefit of HL register is HL register is generally used as representation of memory location and it is denoted by M. So next we'll see our special purpose register. So first we'll come into the category of user accessible. So in this we have our accumulator. Accumulator is also called as the processor register, because whatever arithmetic and logical operations we perform, the data gets stored in the accumulator. Again, it is of 8-bit only. Whatever operations we will perform, we will find our result stored in accumulator. Accumulator is generally represented by capital A. Then we have our program counter. Program counter is a 16-bit register because it holds the address value. Basically, program counters tells us the which instruction next is to be fetched. It also tells the flow or the sequence of any program. Next is stack pointer. Stack pointer deals with the stack memory. Stack memory is a separate kind of memory which is within the processor itself, and we have push and pop operations regarding stack. So stack pointer always defines the top of the stack. Okay, now we'll have some special purpose registers. Again continue. So this is a flag register. Flag register is given in front of you. It is an 8-bit register. So S denotes the sign bit, Z denotes the 0 bit, then AC is the auxiliary carry bit, and P is the parity, and CY is the carry. Now I will tell you each and every flag bit how it works, when it is set, when it is reset. So let's talk about first D naught, that is carry flag. Carry flag is generally whenever we do any arithmetic addition or subtraction, whether a carry or a borrow is generated or not. If a carry is generated at the end of the operation, then this carry flag is set to 1. Next we will talk about parity flag. Parity always gives you the number of ones in the result. So if I say that my number of ones is even, then my parity flag will be set to 1, otherwise it will set to 0. Next we have auxiliary carry. Auxiliary carry is always used in BCD kind of addition, where we have 8 bit and where we want a carry from D3 bit to D4 bit. At that time, if a carry is generated, that is when we are moving from lower nibbles to higher nibbles. If a carry is generated, then our auxiliary carry flag will be set to 1, otherwise it will be set to 0. 0 flag tells whether the result in the accumulator is 0 or not. So if the result is 0, for example, if we subtract same number, then the result will be 0. So in that case, 0 flag will be set to 1, otherwise the 0 flag will be set to 0. Sign flag represents the sign of a number, so it is generally the MSB bit, which gives you, if the MSB bit is 1, we know that our number is negative. In that case, the sign will be set to 1. Now there is an example on the right hand side of this slide. You can see that we have a CD and an E9, two numbers, and now we are adding these numbers. So if you see this addition, the result is like this, which is, if I say 1 plus 1 is 0, 1 plus 1 is 0, then you have a 1 carry over here, then 1 plus 1 is 0, then a 1 carry over here, and then 1, and then 1 plus 1 is 0, then again a 1 carry over here, then 1, and so on. So if you see this, is this result 0? No. So our 0 flag will be set to 0 because this result is a non-zero value. Next, if we'll count the number of 4s, 1, 2, 3, 4. So in result there are 4 number of 1s. So that means our parity flag is even. So parity is even, that means parity flag will be set to 1. Now let us see, yes, let's talk about auxiliary. So this carry is generated over here from D3 to D4 bit. So in this case, our auxiliary carry will be set to 1. Next, carry flag. There is a carry over here generated. So our carry flag is also set to 1. Now if you see the MSB is 1. So the sign flag is set to 1. So this is the way we do any arithmetic operation, and then we set our flag values. Next is instruction register and decoder. So instruction register is what? It is a register which gets the instruction, and then that instruction is decoded and we understand what kind of operation is to be performed. Next are temporary registers. So there are two temporary registers, W and Z, which are available in the microprocessor 8085, which are not accessible by the user, but they are generally used in some of the instructions in which the microprocessor needs to hold the data for temporary purpose. Then we have our increment and decrement. So increment and decrement are again, it is as the name says, these are used for incrementing the value or decrementing the value by 1. Next we have address latch. So address latch is a very special kind of a purpose over here. We have our multiplex address and data bus in 8085. If you have studied the pin diagram, you will understand that. So when I talk about this, so this is what, since our address is of 16 bits and our data is of 8 bits, so the lower order address bytes, we take it as multiplex. So what we do, if the ALE value is 1, then all the 16 lines will act as address line. That is, AD0 to AD7 will also carry the address data, and A8 to A15 will also carry the higher order address byte. But if the value of ALE is 0, in that case, AD0 to AD7 becomes your data bus, and it consists of data values, data bytes, and rest the higher order will carry the address details only. So this is used so that we don't need extra 8 pins for the data bus is not required, and we multiplex the lower address bytes. So this is a good feature, and this is been done with this address latch enable. So I hope that the details of the registers in 8085 is almost clear, and hope to see you next time. Thank you.